Today I would like to talk to you about adding and subtracting radicals. And let's hark back to those days when we were adding and subtracting just regular variables and like terms and unlike terms and how we had to handle that situation there. Let's look at a little example here as a lead-in. Let's suppose that we're interested in the number of characters that we have on each line here. Different characters. If we look at the first line, we've got 3 newtons here. So if I'm interested in the number of newtons on that line, I say 3 newtons. Now in the second line, we've got both directs and we've got newtons. So I have to distinguish the two and say that we have 2 directs and 1 newton on that second line. So keep that in mind. In the case of radicals, the radicals have to be the same in order for us to add them together, and the terms outside have to be like variables. So in this case, that's what we have here. So we can add these together and say 15 times the square root of y. Now our next problem is very similar. Our radicals are the same, so that's okay, and we have like terms outside, so we can subtract and get negative 5 times the square root of x. The next problem, though, we're going to have to work a little bit harder. Hark back to those times when we had to simplify radicals. So here we have square roots. We're looking for squares. That first radical, we have a 9 times a 3, and the second one we have a 9 times a 2. So we can pull out a 3 from each of those radicals, but we got to be careful. What's left behind will lead us to radicals that are not alike. So that's the best we can do for our answer. Look at the next problem here. Start out the same way. We're looking for squares underneath the square root. So the first radical there, we've got a 9 times a 2. And then in the second radical, we've got 25 times a 3. So our squares are 9 and 25. Take the square root of those and put them outside the radical there. And so we can pull out a 3 from the first radical and a 5 from the second radical there. And again, our radicals aren't the same, so we can't combine them. Here, we've just got numbers, no variables. So we're square roots again. Look for squares. 8 is 4 times 2. And then 32 is 16 times 2. So 4 and 16 are squares. So we can pull out a 2 from the first radical, and we can pull out a 4 from the second radical. Our radicals are the same, so we can combine them and we'll get a negative 2 times the square root of 2. Next problem here. Under the first radical, we've got an x cubed, so we can make that x squared times x. So there's our square, x squared. And the next, then we have a 4 times 2 underneath the second radical. Now be sure when you pull out something from underneath the radicals that you multiply it times whatever's outside the radical. So we'll end up with 2x times the square root of 2x plus 8x times the square root of 2x. Our radicals the same, so we can add them together, so we get 10x times the square root of 2x. This one here, square roots again. So we have under the first radical 25 times 3, and in the second radical we've got a 3 times a 9, and we also got an x squared times an x. So in the first radical we can pull out a 5, and in the second one we can pull out both a 3 and an x, and our radicals are the same, so we get 2x times the square root of 3xy. This one, watch out, we've got a cube root, so we got to go looking for cubes. So under the first radical we've got an 8 times a 2, and in the second one we've got 27 times 2, so our cubes are 8 and 27, so we can pull out a 2 from the first radical and a 3 from the second radical. The radicals are alike, so we can go ahead and subtract and get a negative cube root of 2. Our final problem here, in the first radical we can take out an a from the a squared, and in the second radical that's 4 times 2, and then we got a y times a y squared, which would make y cubed. So we can pull out both a 2 and a y from the second radical there, and then we're down to this point here in the third line. Now, one thing, we can't combine the radicals because the outside terms are not alike. So we can factor out a square root of 2y. Thank you.